Alright, so today we have this A1706 MacBook Pro motherboard that does not turn on after liquid damage. So as always, let's plug it in and let's see what it does. So, no power after liquid can be numerous things, as anybody knows. Pretty much whatever liquid touches can be the problem. So we get 5 volts and 0.4 milliamps, and it cycles. So cycling USB-C circuit can be a few different things. I just want to check around the USB-C controllers and see if we see any visual signs of damage. But generally, cycling like this can be caused by any of the USB-C controllers not working properly. It could be caused by a short on one of the LDOs. It could be caused by a bunch of stuff. It's kind of a non-specific finding. So let's go ahead and do a visual inspection of the system board under the microscope and see what we can find. So let me switch over to my microscope. And let's see here. So left side CD3215 looks clean. No sign of anything wrong there. Bottom side also looks clean. My mat is a little bit wet. I just cleaned it. If that's what you're seeing there, that's just isopropanol. It's not going to hurt anything. Alright, we have a little corrosion right here, but this is pretty minor unless it's bad enough that that's hard to say. That's looks superficial, but that resistor kind of looks funny. So here's the problem here. The chip is underfilled and it's right near this NAND shield. There's really no pretty way to do this. We're going to have to cut the NAND shield to get access here. Let's see if I can maybe get in here. It's hard to say because that doesn't look that terrible. But I'm going to guess unless this side is corroded too. Nope, that looks fine. So cycling, I forgot to add this. Cycling can also be caused by a ROM communication issue between the CDs and the ROM. Let's go ahead and open a board view. Let's see what that one resistor is, because I'm wondering if that's for the ROM, because ROM communication issues will do this. So let me open a board view for this, and we'll go from there. Alright, so here is our area right here. It looks like... Which one was corroded? I think this one right here. Yeah, that's just going to be a data line for communicating in between these. What about this one? Same thing here. This is going to be to the ROM, I believe. No, where's the ROM? Here's our ROM. Trying to see which of these go to our CD3217 here. It's one of these here. But anyway, what may have happened, we may have a short on one of the 1v1 LDO here, because this could have crossed liquid. But this, I'm almost starting to wonder if this CD3217 is dead. It's going to be hard to say. Here's our ROM communication lines, I think, those I2 squared lines. So at this point, we have a finding that may or may not be related to the issue. Because remember, correlation does not always equal causation. So let's clean this. Let's measure that resistor. Let's see if that resistor is normal. If it is, then we could probably exclude it unless liquid got underneath of it and is all corroded next to this under the underfill right there. That can happen too. So let me just clean this with a little bit of alcohol, and we will see. I don't like to touch these chips if I don't have to. And what do we see here after it's cleaned? That looks like the CD3215 got really, really hot. See that? There's a hole there. Now what that may tell me is that the chip got hot enough. Either one of two things. The chip got hot enough to expel the solder balls from the side, or there's a little hole there off the bat, and it got under here and is now corroded under the underfill. So there's going to be no fun way to do this. I got to pull this CD3215 now. Let me just check around for a short, because this resistor I don't think is going to be the issue. This does not look that bad, and resistors seldomly get damaged in that way just from corrosion. Especially, it's mainly the pad under the pad under the resistor you have to worry about. Like, little corrosion on the top's not going to hurt anything. Let's check 1v1 for short. And this is a problem. This line right here is 3.8 ohms to ground, and that only goes to our CD3215. And that's UPC something or other. It's a 3.3 volt communication line. So I'm going to say our CD3215 is shorted. Now, these are not fun. These are underfilled. They are a pain because you have other underfilled components. So what I'm going to do is we're going to have to most likely reball this too, because oh, look at this. So this is going to be a grommet that was ripped off the board from whoever worked on this last. This is just the ground layer. There is no damage to the underlying layers, so this, we will not worry about this. We're just going to put this back, and yeah, that's doesn't mean anything. So we're probably going to have to reball this CD3215 because it's directly on the other side, and you know, we got to pull it off, and it's underfilled. What I can try and do, I can get a little heatsink and put it over here, but that's probably not going to do any good. But I'll do that just to see if we can avoid reballing the other one, but I'm pretty certain this is going to be our failed chip right here. So we're going to put a thermal pad on this chip, and then we're going to put a penny on top of it. So we're going to put it, let's get this, ow, I just poked myself. Get this LDO off of here, this liquid damage indicator. And let's get our thermal pad on our chip area. Thermal pad is just like kind of like thermal paste. Now, thermal pads in and of itself can pull heat from components. So if you have a little MOSFET or SSD, you could put a thermal pad on it and actually will keep the temperature down. Obviously, it doesn't have very much thermal mass, but it will help a little bit. So I'm going to put the penny here and squish that penny down. So now there's a penny here, and also the penny is going to transfer heat over here to the shield, which has a connection to ground, which is going to help. So we may be all right here. So now I'm just going to make sure I have firm pressure on the board, because I want that little heatsink to stay in place. And then we're going to heat this and take it off. Now I'm going to start at 200 Celsius. I'm going to start by scraping this underfill from around the chip. We don't need flux yet, so we just want to get underfill out from around there, because that's going to make our job ultimately easier. Now, this is not, removing underfilled components from MacBooks is totally different than removing underfilled components from iPhones. The thermal mass of these MacBook boards are much higher, and you're much more likely to rip a pad, so be careful. We don't want to pull that chip off before all solder balls are liquid. So I'm going to get a pair of bent up tweezers here, and I'm going to heat this at 200 Celsius. This is not hot enough to melt solder, so we're not going to hurt anything. And we're just going to scrape away the underfill. Also being relatively gentle because I don't want to damage the PCB. It's coming off nicely. 200 Celsius is usually the sweet spot. Our NAND is also right in this area, so we want to be careful on that, but again, that's not going to be a concern right now because we're not hot enough to melt solder. The scratches are not of concern either. There, that's satisfactory. Get our flux, put it around the chip. It's more of just to keep the joints around it nice because we're not going to get any under there. And we're going to go, remember we have another underfilled chip right there, so I'm going to be on the side of caution. We're going to go 350 degrees Celsius, 355 actually, and we'll go 90 liters per minute on the airflow here. And we're going to start heating. Now, I'm going to be gentle, and I'm going to show you what I'm going to do here. So, we're heating. The board is already preheated from us heating prior. I'm going to keep an eye on the components around it. Once I see them starting to melt, then I'm going to wiggle the chip back and forth gently. And you can see it already is melting under this chip. So, I'm just going to move it back. I'm using like a twisting and lifting gently. And yeah, it's a pain. Another thing you could do too is if you can't get it, stick your tweezers under it like that, like I just did. I don't like to do that because sometimes if you're not careful you can rip pads, but that works and it's off. And you see this disgusting mess right here. Why Apple put CD3217s on this board, I don't know. Let's check the NAND right here for any signs of floating. And the NAND looks good. So we'll put back this capacitor and this other one. Don't really see what happened here, but I'm going to see if my cycling is gone now. Try and clean up some of this stuff beforehand. Flush real quick. And then now I'm going to check on the other side. We'll put all this back that we knocked around, but I want to check and see if my heatsink did its job and pulled enough heat away from this CD3217. And I'm going to go with no, because see what I see right here? I see solder balls on the resistors. But remember, those resistors weren't making contact with the heatsink. Only the chip was. But we will see. We'll see. I think it'll be all right. So let's now, I want to see if our cycling is, actually, let's see if our short is gone. So our short is, well, I guess we should put everything back first. So let me put back this MOSFET. And then our capacitor there. Why my scope keeps going out of focus today. There. A lot of people don't realize how hard it actually is to record and keep the scope in focus and everything, because I'm seeing something totally different through my field of vision that you're seeing. And then you're working on the board, so you're not really paying attention to the recording, but it is what it is. Come on, melt. There we go. That's good. The rest will flow into place when we're done. Just check again for signs of Nope, looks alright. Okay. Check for our short now. Gone. So I do believe that was our issue there. Now we'll plug it in and see if it still cycles. The little alcohol on the board is not a concern. We will get 5 volts because we need all of our CD327, so used to saying CD3217, CD3215s to talk to each other and communicate with the SMC. So and we're still cycling. All right. Maybe that's the case if it's not communicating with one another. I'm not sure. Let's find out. So let's go ahead and get a new CD3215 on here. First off, we need to clear this mess up. So I'm just going to grab my iron, turn on my fume extractor because all that smoke from the underfill is going to be nasty. Just going to clean this up, wick it, and then we'll get a new CD3215 on here and see what the board does. It's also possible we have a short under the other one now. But we'll find out here. Okay. Now I'm just dragging my iron around very gently. My goal is just to dislodge that underfill. We may or may not nick an NC pad doing this. Yep, looks like we got an NC. Maybe, maybe not. I can't tell. Nope, we're good. So you're never going to get all of this off. Don't even try. The main thing that matters is that you get most of it so the chip sits flat. And it looks like we did. We got a sufficient amount off. Use a little bit more. Then we're going to wick this too, and that should correct most of it there. Looks like we nicked a diode, so I'll replace that. I know it's kind of out of focus. I can't help it right now because the board does bow when I put pressure here. Let's clean again. Looking decent. Trim my wick again. That's good enough. Clean really thoroughly and see if there's any traces that need to be jumpered. I don't think there will be, but always best to check. Nope, looks good. We did nick the conformal coating, but traces look fine. Alright, let's grab a new chip. Alright, let's get our new chip on here. So, start with a little bit of flux. Remember, BGA, we don't need that much, so just a little bit. There's some junk in here. I want to get that out of here. Had been a little underfill stuck on my syringe. Get that out of here. So yeah, just a little bit. It'll spread out when we heat it. Orientation here. Looks like the dot is going to be in the bottom corner. Bottom right corner. That's all good there. Cool. Alright, let me check again for floating. I'm very concerned for this chip. And yep. Maybe, maybe not. It's hard to tell. That could have came from that cap. Or it should be alright. But we're just going to have to see if it works or not. Because that penny would have pulled quite a bit of heat. It wouldn't have pulled it from around it. It would have pulled it just from the stuff. It would have pulled it just from the chip, not from the components around it. Let this board cool, and then we will test and see if our issue is resolved, and go from there. Alright, board cooled for about 30 seconds to a minute or so. And let's plug it in and see what we get. So here's our USB-C port. 5 volts, hey, 15 volts, 20 volts, 76 milliamps, 74, that's pretty high. I mean, it's not really high, it's borderline. Let's see what VCore is. 58. Alright, 58 is normal. But I need CPU V-core here. CPU V-core is 6.42 volts, and that means the board is posting. So this should be booting into an operating system. Let's go ahead and unplug it. Let's throw it in the enclosure and see. This board did have liquid damage, so it's got to go through the ultrasonic regardless. But in short, here's what happened. We had a little bit of corrosion that probably jumped 3.3 volts, the 1V1 line, and killed the CD3217. How many times in this video did I say CD3217? CD3215. So that can happen. That's what corrosion is. Let me grab this enclosure real quick, and we'll see if it boots in an operating system. I believe it will. I also want to check both these ports on this side because this was the port that we worked on. But remember, all these things need to talk to each other. If they weren't talking, we would not get 20 volts. Alright, so board is set back in the enclosure. I'm going to try the bottom port first. I want to see which port this actually is. So we could figure out which port is actually being used by just measuring on our USB. C fuse for that area, and that is 1.6 volts, so that's not our used port. We have 20 volts and 0.63 milliamps here. And we have an Apple logo, so I'm going to go ahead and check the next one, which is the one that I was most concerned about because it was one that we might have floated. 5 volts, 0.2, 0.1, cycling. Alright, so we have an issue on the one. I knew it. I didn't trust it from that one solder ball there. So I don't trust it now either. So I'm going to go ahead and replace that because I don't want to reuse something that may possibly had a voltage bridge to it. So we're going to go ahead and replace that CD3215. We don't really have to worry about the other one now, so we don't have to worry about a heatsink or anything because it's already been replaced. There's no more underfill on that. So we still have to be mindful of the NAND near it, but that's not really a concern as long as we're careful. So let's go back over to our microscope. Here's the one in concern. So same thing. Yeah, this one solder ball is what I think right in there, so would not surprise me if there's a bridge under there. So like I showed last time, 200 Celsius. We're going to get a nice pair of bent tweezers. It's funny how bent tweezers always end up being your most useful tools on stuff like this. Heat. And better clean that solder paste off. That cap will solder back on. It's unless the end caps got compromised. Nope, that cap is fine. It just got dislodged. Alright, same thing here. We're going to heat 360 or 350 with 350 to 360. And we'll go 90 on the air. Flux. I'm going to heat until I see the solder balls squishing out the sides, and then I'm going to... It seems to work better if I stick something under the chip and lift up on it rather than otherwise, so that's what I'm going to do. Then I just remembered we also have a diode we need to take care of. The main thing is I just want to make sure that the chip is fully melted on all balls because I do not want any rip pads on anything important. Should be free now. And it's off. Let's fix what we broke over here. Not broke, it's probably the wrong term to use, but fix what got loose. Come on, little resistor. There, we'll touch you up later, but that's back in place. Let's start with underfill cleaning. So remember what I did last time? I got my tweezers, and we did get a pad right there. Let's see what that's for. I'm guessing that's NC. Yep. No concern. Another one here, and that one is also NC. Yeah, it happens, unfortunately. Just want to get like the really thick areas. If something's not coming off freely, then I'll just get it with my iron in a second. Fume extractor so I don't get lung cancer from this underfill. Now, it's also important to note, when I'm doing this, I am not using pressure. I'm barely resting that iron and just moving it. Let the heat do the work for you. That's done. Now we clean it. And the rest will be taken care of in wicking. I just want to clean around this resistor here. And right here. I'm gonna guess that most of our underfill is also gone by now. We'll see here. Beautiful. Look at that. All gone. Totally flat surface. Before I put this chip down, I want to take care of the one area that I did have to be concerned about, which was this resistor here that didn't want to go down fully because there was this little blob of underfill around it. And then that cap right there. That sizzling you hear is the isopropanol boiling. If you can hear it. I don't even know if my mic picked up on that, but that's just the isopropanol under that shield boiling. And I don't like how this cap sat. There. That's good. Alright, time for our new chip. Alright, let's get our new chip on the board. Orientation is in the bottom right, just as the other side. Flux. Went into place a little bit funny there, but it looks good. Let's let it cool, and then we will see if our symptoms on the board improved. I think it'll be fine. We'll see here. This is going to need some conformal coating right here after ultrasonic. We'll just put a little bit on that just so it isn't exposed like that, because I don't like leaving stuff like that. Then this should be good. This cap's a little bit off here. Looks like actually we have a tiny little bridge right there. See that? I don't know if it's a bridge or the trace. That is a bridge. Glad I saw that. That cap needs to be straight. Let's throw the board back in the enclosure and see what we get. Alright, we're back in the enclosure. Bottom port, as you can see, we're going to plug it in. And we are getting 5 volts, 0.1, 9 volts, 20 volts, and 0.78 milliamps. That is good to go. Let's just wait for this to boot into enclosure. The battery's unplugged, so the CPU is going to be throttled to like 8.8 something megahertz, 800 megahertz or so, maybe a little bit higher. We get trackpad click. I didn't plug in the display. That's required, don't you think? Alright. Done that before. I don't plug in the display and I'm like, why isn't it posting? Yeah, dummy. Display is not plugged in. .63, and it posted. It's an Apple logo, and that is a booting MacBook. So this is fixed, and thank you for watching.